I've put the link for these slides here on the title slide if you'd like to follow along with your own copy. While scanning the news, Beth reads an article about the creation of a new spaceport. Finds that there's not yet a Wikidata item for this spaceport and decides to create a new item. Beth does not want to spend too much time figuring out what properties would be best to use to fill out this new item. Beth can use the ShEx schema E213 as a template for creating the statements for her new item. The ShEx schema indicates properties that Beth may want to consider using, such as instance of what country the spaceport is in, who the operator is, maybe an image if there's one in Commons, etc. Sometimes editors want to quickly create new items in domains that they haven't yet explored in Wikidata. In this case, Beth found the spaceport schema in the e-namespace, made use of it, and now her new item is modeled in harmony with the other spaceport items that already exist in Wikidata. In this way, schemas are data models. Wikidata's e-namespace is entirely dedicated to schemas. More than 200 schemas have been contributed since the namespace first became available in May of 2019. Due to the fact that Wikidata supports multiple data models per domain, it is sometimes possible to express a statement in multiple ways. In some cases, this is necessary and desirable. In other cases, it will be possible to build consensus around a single shared model. The ShEx language is a formal language for data modeling and data validation for RDF graphs. ShEx allows humans and machines to communicate unambiguously about data assets. The ShEx compact syntax is designed to be readable for people who are familiar with Turtle or Sparkle. It has already been demonstrated in the research that many Wikidatans increase their knowledge of Sparkle through interaction with the Wikidata query service and by learning from others in the community and Sparkle queries that others share. If this pattern holds true for ShEx, members of the Wikidata community are likely to find the ShEx compact syntax more and more readable over time as they become more familiar with it. And over time, editors may find ShEx schemas useful for a wide variety of tasks related to working with Wikidata, some on the data modeling side and others related to data validation. So ShEx is a language that allows humans to communicate with machines and, I would argue, other people as well. An example of contrasting models is found with the use of property P512, academic degree. I've observed that there are multiple patterns in use for describing members of the National Academies of Science and how their academic degrees are modeled in Wikidata. So some have been described with academic degree as a predicate and then the value of PhD. Others have a qualifier predicate for academic degree, modifying their P69 educated at statement. Both of these query patterns would need to be combined in order for the results from Wikidata to be more complete. And people who might like to reuse Wikidata could become frustrated by needing to identify multiple closely related modeling patterns. And of course, this is just one example of many. And I didn't choose this one for any particular reason, but just because it's kind of small and I could show it quickly. But obviously, this is an even more complicated problem the larger the data model and the greater number of properties and qualifiers involved in the contrasting patterns. So this is often a result of editors not being aware of one another's work. If someone does notice that there are multiple patterns in use, there's no single place for the discussion about a solution. Some people might discuss it on the talk page of an item if that's where they see the issue come up. Some people might discuss this on the talk page for the property, which is a great place to discuss it, but it requires that other people are also paying attention to the talk page of that property. And that's just not always the case. There may be other people interested in this model who aren't yet watching the talk page for the property. Some people might choose to discuss the issue on project chat. Again, another great place to talk about it, but those discussions don't always get the attention of everyone who is interested, and sometimes the issue is just not resolved. If an editor proposes a schema, the models can be discussed holistically on the talk page for that schema, rather than discussing a single property at a time. And the benefit of having the discussion on the talk page for a schema is that I hope that over time, this can be a more widely recognized place for consolidation of discussions at the model level. And even if the proposed schema starts out just describing one of the patterns, it can be a great place for the community to decide if there are favorable aspects of one pattern or parts of the second pattern that need to be brought in to build consensus around one model that can satisfy all of our needs, or hopefully as many of them as we can get. So this is the example I just provided is one where it would be desirable to build consensus around a single model for expressing the academic degree, not just for members of the National Academy of Sciences, but anyone who has an academic degree on their item. And I say that so that reusers of Wikidata can expect a more consistent set of results that hopefully they can feel over time is going to be a more complete set of results, rather than feeling like right now they may need to investigate themselves if how complete these results are, and if there are other variant patterns that they may need to modify their query to take account of. So we've already covered how schemas are used to communicate data models. Now, where do we find these models? We can bring external schemas into Wikidata. A concrete example of this, there are two schemas in namespace E related to Pronom, the technical registry of file formats maintained by the National Archives of the UK. And both of these schemas here, E79 and E237, reuse portions of the Pronom data model. And because this is a widely used registry related to formats, it makes sense that Wikidata's data model related to file formats be inspired by parts of the Pronom data model. If there's not yet a schema available in Wikidata and we're not aware of an appropriate external source, there's still a chance that we may be able to use Wikidata to help us get closer to our desired model. We can try extracting a schema from Wikidata. Two tools that I would recommend trying out are ShExer from the WESO lab at the University of Oviedo in Spain, and shape designer from the University of Lille in France. It's even possible to extract schemas from a different Wikibase. For this, you could try Yashi, also from the WESO lab. These tools process a sample set of items from a class based off a SPARQL query and derive the properties and qualifiers used on those statements or those items into a ShEx schema. Once you extract a schema, you may need to prune it or massage it a bit further to get it to do exactly what you're hoping for. But it's a great way to get a head start on understanding how data is already being modeled in Wikidata. So how are people developing these tools? By reusing one of the libraries for the 5 current implementations of ShEx. So there's ShEx.js, which is the JavaScript implementation, ShACLEx, which is the Scala implementation. There is ShEx Java, PyShEx, and RubyShEx. And all of these are available. All the links are here in the slides, and they're all available under open source licenses. While I'm discussing implementations, I'll also mention that ShEx has a comprehensive test suite that includes 1,103 validation tests, 99 negative syntax tests, 14 negative structure tests, and 431 schema conversion tests. And if you'd like to try out ShEx with your own RDF data, there are some online validators that you can work with. The first link here is to the ShEx2 simple online validator based on the JavaScript implementation. And this is the same validator that you get if you go to Wikidata's e-namespace and you use one of the schemas there to validate data from Wikidata. This is the validator that comes up in that interaction. There's another online validator, RDF Shape, and this is based on the Scala implementation and is also from the WESO lab at the University of Oviedo. Now I'd like to talk about Wikidata's e-namespace as an interlinked ecosystem of schemas that we can all edit. To get an overview of the current inventory of schemas available, I'd recommend this page created by user BA Myers 99. This is just a detail from the larger Schema Gallery page, and I found this to be really helpful for browsing the existing schemas. If you'd like to search for a schema, you can also use the advanced search options and restrict your search to the schema namespace and find schemas through search. So what we see here in the Schema Gallery, there is the label listed along with the e-identifier for the schema, a brief description of what the schema is intended to do, aliases if there are any, the class that the schema focuses on, and then the last column, dependencies, any schemas that are related to this schema that either import it or are imported by it. And I'll return to the concept of importing a schema in just a few minutes. I'd like to highlight the fact that ShEx schemas work across human languages. So here's an example of a schema for hospital. And you can see in the shape names and in the comments and even in parts of the prefix have all been translated. Elaborating schemas in Wikidata's e-namespace allows editors to leverage the multilingual support of Wikibase to share data models across language communities. So schemas can be written in any of the languages supported by Wikidata. And if you're looking at a schema that is written in a language that you don't know, you can make use of a user script called Entity Schema Highlighter. And that will allow you to hover over the PIDs and QIDs to get the labels in your preferred language. And I'm really excited about this aspect of the potential for multilingual data modeling, where users, even if they don't share a spoken language or a written language, we can, through the power of building these schemas in Wikidata itself, we can do collaborative data modeling across language boundaries. And I think that this is a really exciting feature. And if you browse through the e-namespace now, there are already schemas in several different languages. And I look forward to a future where there are going to be schemas in many, many additional languages. So to return to the concept of importing schemas, it's possible to reference shape expressions and triple expressions from another schema. This is helpful because we can reuse shapes as building blocks. And not only does this enhance consistent modeling, because you're not trying to redescribe the same thing, you're just using shapes that are already created. It can also save you time as the schema author, because if there is a relevant shape that has already been created, you can just import that into the schema you're working on. If you browse through the schemas that have already been contributed, you'll see that quite a few are already making use of import. And so in this way, we already have a web of interlinked schemas. And of course, there is still plenty more work for us all to do. So what's next? More editors will contribute schemas. More schemas will be interlinked via import. This ecosystem of interlinked schemas will support the work of more editors. And Wikidatans will create more tooling that leverages schemas. I think this ties in nicely with the points that Lydia made earlier in the workshop about building consensus around shared data models. Once editors have awareness of patterns in editing that help contextualize the single item that they're working with, we will likely see the number of variant patterns go down. And as Lydia mentioned earlier, right now, the interface really encourages editors to focus on the single item that they're editing, if they're editing manually. And if they're editing by bot, then they may not be looking at the structures of every single item that their bot is going to touch. And so they just might overlook variant patterns. But if bot designers are working from schemas, that could be another powerful way to increase the number of bots working in harmony with existing data models and reduce the number of variant patterns. And I believe that Wikidata's e-namespace will become known as a useful repository of data models, even for applications beyond Wikidata itself. If you'd like to review the literature about ShEx, I recommend checking out the Scholia concept page for ShEx. It's linked here in the slides, and you can get a list of recent papers and books published about ShEx, and of course, all of the wonderful Scholia visualizations related to who's writing about ShEx and what are the venues where ShEx is being talked about and where papers are being published. If you'd like to see some more resources about getting started with ShEx, I'd like to point out Jose Labra's Wikipedia Weekly Entity Schemas and Shape Expressions session. There's a link to the YouTube recording of that Wikipedia Weekly session here in the slides, and it's a great overview. There's a link to the ShEx primer, which is perhaps more readable than the spec itself. Today, I think actually partially overlapping with this Wikidata workshop, there was a tutorial also given by Jose Labra called Shapes, Applications, and Tools. If you weren't able to participate in that tutorial because you were here attending the Wikidata workshop, I put the link in because Jose has made all of his slides available and links to all of the resources that you may find interesting to explore on your own time. And of course, you could read the book, Validating RDF Data, and I put a link to the HTML version of the book here. So you can read that on the web. For getting started with ShEx on Wikidata, there is a wiki project for schemas. And then I also put in a link here to browse the gallery of schemas. Just as knowledge is power, our structures of knowledge representation are powerful lenses of data structuring. I personally feel positive about my agency creating data models in Wikidata's e-namespace. If we create these models in open systems using peer production, we will not have to rely on data models from elsewhere, maybe supplied by corporations, which are created based on their value systems and their priorities. Let's build the models that we need to describe the world that we know and we see around us and we want to have as our future. Thank you.